Hello everyone, we are Group 3. Diabetes is a growing public health challenge. According to CDC, over 40 million people in the US are currently living with the condition, with type 2 diabetes accounting for up to 95% of all the diagnosed cases. Poor glycemic control can lead to serious complications, including cardiovascular disease and kidney failure, which significantly impact patient quality of life. For years, we relied on standard finger stick, but its data only tell us what's happening at the moment. Today, we're seeing a digital evolution. Continuous glucose monitoring and smartwatch integration provide real-time trend analysis and automated alerts for abnormal glucose level. Organizations like the American Diabetes Association now emphasize this digital shift to improve patient awareness and allow for faster intervention. As nurses, our role is critical. We are the bridge to technology adoption and the front line of patient education. By advocating for advanced monitoring, we can help reduce complication and improve long-term patient outcome.
The purpose of this study was to evaluate whether continuous glucose monitoring through smartwatch integrated CGM improves glycemic control compared to traditional fingerstick monitoring. Specifically, we focused on adults with type 2 diabetes in primary care settings and looked at the outcomes over the following 6 months. We wanted to see if real-time glucose feedback could lead to greater reductions in HbA1c levels. By comparing these two approaches, our goal was to determine if newer CGM technology offered a more effective and practical way to support long-term diabetes management and improve patient outcomes.
So for this project, our research articles were collected through a database searches using the University of Nevada, Las Vegas library. The databases included PubMed, SynHall, and Medline. Those were our 3 top ones that we used. Some of the key terms that we used were such as glycemic control, blood glucose control, A1C, type 2 diabetes, smartwatch, as well as self-monitoring, finger stick glucose monitoring, and those were some of the terms that we really used to emphasize it to fit to our PICO question. The articles were selected based off the relevance to our actual PICO question because we wanted to make sure we were specifically focusing on the population of type 2 diabetes and those who use the A1C levels to be able to monitor that glycemic control. And then finally, our articles were selected using our grade framework, which helped us to see the quality and the strength of these articles and how well they fit into our PICO question.
The summary of evidence showed that continuous glucose monitoring consistently outperformed traditional fingerstick methods. Across multiple randomized controlled trials, continuous glucose monitoring was associated with greater reductions in hemoglobin A1c, increased time spent in target glucose range, and fewer episodes of hyperglycemia. Patients also benefited from real-time feedback, which supported better self-management and awareness of their glucose patterns. These improvements were sustained over time with continued glucose monitoring use, highlighting its effectiveness as a long-term tool for managing type 2 diabetes in both clinical and real-world settings.
While the studies we reviewed provide valuable insights, there are several limitations to consider. First, the sample sizes varied significantly, ranging from fewer than 50 participants to over 7,000, which may affect the reliability and statistical power of some findings, particularly those in smaller studies. Additionally, there were differences in study design, including a mix of randomized controlled trials, observational studies, and one narrative review. Some studies also lacked blinding or were open label, increasing the risk of bias. Another limitation is population variability, as participants differed in diabetes type, insulin use, and demographics. And the studies were conducted across multiple countries, which may impact generalizability. Lastly, there was inconsistent subgroup representation, with some studies lacking full participation or detailed subgroup analysis, making it more difficult to apply findings to specific patient populations.
In conclusion, current evidence shows that continuous glucose monitoring, or CGM, including smartwatch-based systems, is more effective than traditional fingerstick monitoring for improving glycemic control in adults with type 2 diabetes. Across multiple studies, CGM was consistently associated with lower A1C levels and improved glucose stability. A key benefit is the real-time feedback it provides, which helps patients better understand their glucose patterns and supports improved daily decision-making and self-management. Even though there were some differences in study designs and populations, the findings remained consistent, which strengthens the reliability of the evidence. From a clinical perspective, CGM should be considered for integration into routine care, as it has the potential to improve patient outcome and reduce long-term complications. However, more research is still needed to evaluate long-term effectiveness, cost, and accessibility for diverse populations. Overall, this supports moving towards more technology-based approaches in diabetes care to enhance patient safety and quality of life.